Hello, students. Today, ladies and gentlemen, we are going to begin our first real topic of the year this year, topic number one, which happens to be microscopes. So let's dive right into our topic on microscopes. While you're getting your books open to your lesson notes page so you're all ready to go, why don't we look at some pictures while we're waiting? Starting with, not that one, golly, that was like the top of my head. No, let's start with a picture of a really cool diagram, which you can also see in your book throughout this topic. This is a picture of Robert Hooke's microscope. And if you look at this picture of a microscope, it's really cool. I love like 19th century technology from the 1800s and before, and this was from before. But check this out. This is the microscope itself. Here's a light source in the form of a candle with a mirror shining light with a lens onto the area where the specimen was placed, and all sorts of other funky stuff. It's really cool. But microscopes open up a whole new world of things that are not seen with the ordinary unaided eyeball. We can see a lot of stuff with our eye, but the microscopic world is that much cooler because we can't see it without a tool called a microscope. Now, some microscopes are more powerful than others, and some of the most powerful microscopes, the electron microscopes, which we won't be using in school because they're like millions of dollars, although it would be cool. But here's some pictures from an electron microscope. You've probably heard how ants are very busy and industrious and work well. Well, here is a picture of a worker ant on his way to work carrying his uh, it looks like a briefcase. So maybe he's on his way to the office. Here's a slightly close-up view of the ant's face, and golly, check out his eyeball. This is a compound eye made up of many little facets, and it looks like he's got some eye jib in there. Maybe that's a little eye boogie. I'm not sure. But look at his mouth. This is his mouth right here, and notice the similarity in shape between my hand and his mouth. Isn't that amazing? His mouth looks like my hand, but those are like his lips that close in. I wonder if he's hungry. Should we give him something to eat? Here, let's see if he's hungry. Ooh, oh. No, I guess he's not hungry. Okay, but that's the mouth of an ant viewed really close. And check out his antennae up there, how wild they are. Oh, you just want to, it's like a big teddy bear. Don't you want to just give him a big hug? I hope none of you have arachnophobia because if you know what arachnophobia is, it's the fear of these things. And this is I'm just getting the willies just getting this close to him. Oh, he's got this furry stuff on him, and look at his eyeballs. Altogether, this creature has 8 eyeballs and 8 legs. This is a spider. Pretty freaky picture of a spider. Ooh, and if you've ever had a picnic, you've probably been visited by a fly. Here's the leg of a fly, and here's the skin. Check out his skin and the hairs on his body. Oh, yes. What a lovely thought. Looks like he needs a shampoo. Oh, goodness. Now, there's a face only a mother could love. How would you like to meet this in a dark alley one day? This actually is, well, comes from flies after they lay eggs, and their eggs hatch and start chewing onto the surface of decaying food. This is a maggot face. Hello, maggot. Oh, you're so handsome. Oh, my goodness gracious. Look at this. Oh, no, don't eat my head. No. Golly. Oh, I hope he's not hungry. Oh, these are cool This is a water bear. They're found in mossy environments, but they are such cool critters that scientists have been studying them for a while because they have recently been found to be able to survive the vacuum of space, believe it or not. And then they're reanimated. They're almost like brought back to life, except they don't die very easily. They've been found in thousands of year old ice and they've been reanimated. These suckers can teach us something about surviving really extreme environments. The water bear. And they're kind of cute too. Oh, golly gee, this one makes me itch. Have you ever heard the expression, night night, don't let the bed bugs bite? Well, this is a skin mite. This is a skin mite. Have you ever had just a little itch that you had to scratch, like on your eyebrow or on your skin somewhere? Maybe some of you are starting to itch a little bit now. These are skin mites, and skin mites, among many other creatures, are living on you and in you right now. Skin mites live on you, and they're a very important part of your body's ecosystem. All of the dead skin cells that you produce, you can thank these recyclers for chowing down on them and eating them up. And the different colors you see here actually are threads in a pillowcase. This brown stuff here, those are dead skin cells. And here is our skin mite. So, we are, if you ever feel alone, you're never really alone because we are surrounded by critters like these all the time. But again, we can be thankful for skin mites for cleaning up after we lose our millions of skin cells every day. Oh, goodness. Here is a louse on someone's skin, and you can see it's filled with blood and getting ready to probably lay its eggs. And here's another image of some head lice looking for the scalp of someone's hair. These strands here is someone's hair, and these are the head lice looking for someone or somewhere. They've already found someone. They're looking for somewhere to set up shop and chow down on your blood in order to lay their eggs and carry on the next generation. Here's a head louse that is special to me, not because it was on me, it was on someone else that I removed. And I made this slide myself, and you can see it is filled with someone's blood. Head lice are not uncommon, especially among kids such as yourselves. That's why you should not be sharing hats or hoods or even masks for that matter. Keep your things to yourself so that you don't spread lice to one another. Oh, lovely. Here are a couple of bed bugs. These are a couple of bed bugs that are making more bed bugs. And we'll move on to the next slide here. Give them some privacy as we check out something even smaller than bugs. This is a super magnified image with an electron microscope of bacteria. You have swarms of bacteria living in your gut right now, thankfully, because they help you digest your food. But these are a variety of different kind of bacteria. So we've got little critters living on us, in us, next to us, around us, all the time. So you're never alone. By the way, is anyone starting to itch a little bit, thinking about all these critters living nearby? Ooh. All right. Well, if that's grossing you out, let's move to today's topic, which is the microscope. And let's get right down to it and dissect this word. Dissecting this word, if you remember from last week, examining prefixes, suffixes, root words, we can learn a lot more about the meaning of words and be able to better understand them. So the word microscope dissected in half, and we've got two parts. First half, I think you should know pretty well by now. Micro, I want you to yell out what you think the prefix micro means. Nice job. Now, scope. We're not talking about like mouthwash scope, but microscope, telescope, and words like that. What do you think scope means? If you know, yell it out. All right, let's put them both together. And microscope literally means micro means small, scope means to see. So when we put them both together, small, see, well, what does that mean? Well, a microscope is an instrument used to see very small objects. Microscope, instrument used to see very small objects. Now, when you hear the word, while you're writing that down, when you hear the word microscope, I'm sure something may automatically pop into your brain and you visualize a picture of a typical microscope. But I'm here to tell you that there are different kinds of microscopes, and we're going to be using different kinds in the laboratory. So let's start out with the simplest, shall we? The simplest form of microscope is called a simple microscope, and you all have two of them on you right now. Your eyeball and your eyeballs have a simple microscope in them because your eyeball, the human eye, has a lens. And this lens, which is not dissimilar from a hand lens that you may have used and are familiar with, these lenses do something with light and enable you to see things in a magnified fashion. So, human eye, hand lens, and if you wear glasses like I have to wear now, glasses are a type of simple microscope as well. Simple microscopes have one convex lens, which means it's thicker in the middle. Let me go to the laboratory, and of course, after I put my glasses on so that I can see, let me go to the laboratory and show you a couple of examples of simple microscopes. Okay? First of all, the eyeball. Here's a model of the eyeball. Why does it feel like somebody's watching me? Here's an eyeball. And again, inside the eyeball, I'm not going to take this apart because it really grosses me out when people play around with their eyeballs. But if you were to look inside your eyeball, there is a transparent lens that functions as a simple microscope. Next, we've got hand lenses. You're probably familiar with these. Hand lenses, a type of simple microscope. And again, when you look through these simple microscopes, it helps to magnify things so that you can see things closer than they actually are or bigger than they actually are. Woo, I see you. Okay. All right, let's head back to our notes. Back to our notes here. So, these are examples of simple microscopes, convex lenses, the eyeball, hand lens, glasses, good examples of simple microscopes. Oh, there's me. Oh, what a handsome fellow, and what lovely eyes he has. Now, I mentioned that word convex lens to you. Let's explore that just a little bit further. Convex lens, and think back to sixth grade when you learned about astronomy. You did a little section on lenses and learned about different kinds of lenses. Maybe even you made a telescope, if you recall. Well, a convex lens is one that is thicker in the middle. It's thicker in the middle, and if you see, it's thicker in the middle, thinner on the edges. And the thickness, the change in thickness of a lens allows the speed of light to change as it travels through the lens from one direction to another. And as it changes the speed of light traveling through the lens, it redirects its path. It bends light. In science, we call that refract. Refracting is the bending of light. So a convex lens will refract light or bend it to a focal point. So if you've ever taken a hand lens like this, maybe on a sunny day, and you have allowed the sun to shine through it, you've probably noticed that the sun shines through to a specific point and it gets really hot. So be careful. Don't play with lenses because you know what could happen? You could start a fire. Fires can start that way. So be very, very careful. By the way, some forest fires, like some out west, may have been started by somebody littering, taking a glass bottle, throwing it out the window, having it break, or even if it doesn't break, landing on the ground where there's like leaf litter. And as light shines through that curved glass surface, just like a convex lens, can direct the light to a focal point and actually ignite a fire. So be really careful and don't litter. So what are some other examples? Well, again, the lens in your eye, great example of a convex lens. Also, a drop of water. When you do your home activity this week, you're going to be experimenting with a drop of water as a convex lens. Check it out when you get to your home activity. Now, there's another thing about lenses called focal length, and this is going to be really, really important in terms of understanding microscopes, especially the ones we're going to talk about next. But let's focus on focal length before we go on. The focal length is what determines the magnification power of a lens, of a microscope. And it's the actual curvature that determines the focal length. The fatter or the thicker the lens, the shorter the focal length. The thinner the lens, the longer the focal length. The focal length is really the distance from the lens to the focal point. But take note, lenses with more curvature magnify more. So the thicker the magnifying glass or the thicker the lens, you're going to see things bigger. Incidentally, our eyeballs, I know I wasn't going to play with this, but our eyeballs have muscles inside them that change the shape of our lens. When you look at something really close or far away, your muscles change the shape of the lens. Tomorrow, we're going to do a little activity together, and we're going to feel the muscles in our eye, believe it or not. We're going to have a little eye workout this week. All right, next type of microscope is called a compound microscope. A compound microscope. A compound microscope is one that uses two lenses called eyepiece and objective lenses. And these two lenses, with their different curvatures and their different magnifying powers, are multiplied together. The eyepiece lens and the objective lens, the power of those two lenses are multiplied together. They are multiplied together to determine the overall magnification of that particular microscope. And because they zoom in so much, they require a light source. So let me give you an example. Let me show you an example of a compound microscope in the lab. Join me in the lab. All right, so here we have a compound microscope. Here's the eyepiece lens, which is typically a lens that has a magnification power of 10 times, and various objective lenses down below. And we're going to be learning not only how to use this compound microscope, but we're going to learn how to calculate the magnification power using the different lenses that face down toward your specimen. So we're going to spend a lot of time tomorrow learning a lot more about the compound microscope. But hey, let's get back to our notes now. All right, so compound microscopes, because they zoom in so much, they require a light source in order to brighten up what you're looking at. All right, back to the compound microscope for a moment. Oh boy, compound microscopes, they were improved upon. Does this name look familiar to you? It's pronounced Leeuwenhoek. And can you all tell me who is Leeuwenhoek? Why should we know him this week? Leeuwenhoek is our... Very good, our scientist of the week. And Leeuwenhoek's claim to fame is that he is known as the father of microbiology. Remember, micro means small. Bio means life, living things. And logy is the study of something. So microbiology, big word, but it simply means the study of really small living things. That's it. The father of really small living things. So I'm going to stop our notes here for the day on compound microscope. And tomorrow we're going to spend some time learning how to use our compound microscopes. And I'll introduce you to another type of microscope as well. One of my favorites. I love it. But we're going to have to wait until tomorrow to find out the rest of the story for Microscopes. So I hope you're enjoying this so far, and I'll see you tomorrow.